Our next speaker, Victor Lupaescu, manages the big data, analytics, and DevOps communities at Cognizant Softvision. Before taking on the role of community manager, he helped various businesses shift from gut-based to data-driven decisions by designing and implementing complete business intelligence solutions. In his presentation today, he will show us why, in his field, every second counts. Welcome, Victor. Thank you.
Thank you, Alexandru. Thanks a lot for the nice intro. Like Alexandru said, today's session is about why every second counts. We might take this for granted. We know that an application should be fast. At least it's what we're told. During this presentation, I want to go a little bit through a case study that we've done for one of our customers, where we wanted to touch point exactly how latency impacts performance. At the same time, you can use this as a guideline on how you can do this for your customers or for your business. Of course, you might need to fine-tune it a little bit. As for the agenda for today, we'll go through a couple of steps. First of all, to see if performance does actually matter. Then we'll go through how we monitor performance, then on how we monitor conversion. Then we'll see how we can check for a correlation between performance and conversion, and then how we can confirm the hypothesis or not. First of all, does performance matter? Well, at least some companies say it does, and I'll show you some quick facts around it. There were various studies done before, and one of them said that 50% of consumers expect a page to load in less than 2 seconds. Another study showed that 40% of the users abandon a website that takes more than 5 seconds to load. 52% say that quick page loading is important to their site loyalty. And various studies have shown that 1 second delay can result in up to 10% drop in sales. Moreover, Google takes into account your website response time in order to establish your ranking in Google search, and actually provides a tool for calculating your performance score. This tool is called Lighthouse, is free to use. You can check it out. So I've told you we're going to go through some quick facts, but it took quite a while. So I would say these are slow facts. And the key point here is that users don't like to wait. We've seen these kind of studies before when we were working with this customer. However, we were not really happy taking something for granted. And we put together all the studies that we could find. We've seen that Amazon did a test where they delayed their website with 1 second. The result was a drop of 10% in sales. Google did actually by mistake a 0.5 seconds delay on their Google search engine. What they did there was actually increasing the number of results on the first page from 10 to 20. And their click-through rate dropped 25%, and they couldn't figure out why. And the actual reason behind it is that those extra 10 results resulted in an increased response time from 0.3 to 0.8 seconds. And that actually was the thing that drove that drop in click-through rate. You can see various other studies mentioned here. I won't go into details, but the main thing is that all various companies have seen that a slower response time affects sales or the actual final number when we're talking about a website, of course, or an application. Our e-commerce website was, our e-commerce client was really focused on having the numbers for every decision that they took. It was a 100% data-driven company. So whenever we talked about, okay, we should improve performance, they said, okay, but what's in for us? How much should we invest in performance and how much can we get back? And at the end of the presentation, I'll try to show you what our conclusion was. Now, I've told you we're going to talk about performance monitoring. I won't go into a lot of details here, but keep in mind that tracking is useful. Every application or website logs, or it should log, as much data as possible, of course, keeping privacy in mind. Main areas that you should always think about monitoring, but again, it really depends on your business or on your client's business, are visitors, number of visitors, number of page views, number of orders, orders value in dollars, and performance. How fast is the application or the website for your end users? And always more data means more insights, because of course you have all that raw data, which can later be used for getting those insights. If we talk strictly about performance metrics, keep in mind that you always monitor, okay, what's the response time for a specific user, or at least that's how you should tend to do it. But then you'll come to the point where you have to aggregate all that data, right, in order to get those insights. You have various options for doing that. Average is one of them, but we always avoided using averages because the average is always impacted by outliers, by high values and by low values. Median, in this case, is a much better way of aggregating the data. That median will tell you that 50% of the users have a response time of X or lower than X. The other 50% have a response time greater than X. Another thing we've looked into is the 90th percentile, which again told us that 90% of the users had a response time of X or lower than X, which really helps seeing the long tail. And the 99th percentile, where you still might include some outliers, but you exclude most of them. Maximum is another way, but again, that will be, of course, it will basically be the outlier, the most outlier from your data. One thing you will have to keep in mind is being careful when aggregating already aggregated values, because that might result in some discrepancies. This is how we've looked into performance from a monitoring point of view for customers. We had various page types like homepage, product page, browse page, cart checkout page, and so on. And we wanted to see that the performance is steady or improves based on what improvements we do within the code or within the hardware. We had some targets there for TP50, which is the median, and TP90, the 90th percentile. And whenever the threshold was over that value, we received an alert. As you can see at this point, our median time was a little bit over the actual target, and we really had to work on bringing it down. In terms of conversion, again, it really depends what conversion means for you. For an e-commerce website, we usually look into orders per unique visitors and revenue per unique visitor. Now, the nicest thing about what we've done there was trying to see if there is a correlation between performance and conversion. Meaning, if we improve the response time of the website, does that result in more dollars at the end or not? Or the opposite, if somehow we, let's say we implement a feature that brings the response time to an upper value, does that actually impact conversion in a negative way? And we always tried to see what's the hotspot between these, because you might need some features on the website which might bring you extra dollars. But again, you might want to keep an eye on the latency or on performance to see if it's not actually a negative result. The methodology, I'll explain it quite straightforward here. Of course, it involved more steps in the back kitchen, let's say. But what we did in summary was calculating the response time for each user, calculate the total sales for each user. Then we split the users into response time bins. So if you look at the chart on the right side, the x-axis represents the response time. So from left to right, you have a higher response time. And then we've added conversion into the picture. And the orange line is the conversion. And you can see for the group which had a response time between 0 and 1 second, the conversion was $5.3 per user. Between 1 and 2 seconds, it was $5.22 per user. And then we had a huge drop between 2 and 3 seconds. We got to $3.74 per user, and so on. And you can see the curve tends to flatten at the end. Now, this wasn't like the definitive answer for us, because we wanted to see, okay, does the page that the user is in matters? And what we found out was that some pages or flows might have a stronger correlation than others. And I'll give you a quick tip on that. What we've seen is that homepage matters, but not so much. Browse page doesn't actually matter that much, but the product page is the one that matters the most. So when I think about an e-commerce website, someone goes on the homepage and then tries to go through various products. If that product page loads slowly, they'll might go through fewer products, they might get bored. There are various, psychological reasons behind it. And by using this technique, you can identify where to focus first. And another example, which actually helped us in making sure that we were on the right way, what we've seen is that the cart checkout page performance doesn't matter at all. So once a user added a product into the cart, his buying decision is quite high. And then when he goes to the cart checkout page, he will be open, let's say, to wait for, 5-6 seconds, whatever. It doesn't really matter anymore. But again, it was our case. Don't take it for granted. And doing this allowed us to optimize how we use our resources, both in terms of hardware and in terms of, let's say, mindware, because we had engineers working on improving the performance. By doing this analysis, we were able to pinpoint that they should focus more and try to improve the response time of the product page compared to other pages, let's say. What we also did here, because it was interesting as a one-time study, but we also wanted to productionalize this effort, because we thought that, okay, now we might have a response and median response time of 1.5 seconds, but what if we get to a point where it's 0.8 seconds? Will then matter if we improve it more or not? And what we did was provide a quick dashboard to the stakeholders that they could use. They could choose the platform that they wanted to do the analysis for, which is desktop, when someone opens the website from a laptop or from a PC. Touch, when they open from a tablet, or app, if we're talking about iOS or Android apps. We had specialized apps for both of the platforms. Then they were able to choose the page type, so if it's a product page, homepage, and so on. And what it actually allowed them is to see the curve, the correlation curve between response time and conversion for each kind of these pages, choose a time range, so they had more data available. And then the really nice thing about it is that they could enter, on the right side, you can see TP50 estimated improvement in milliseconds. They could enter a value. They would say, okay, what if I would improve the response time with 200 milliseconds? What would happen then? And they could have a quick figure that they could use for seeing if it's worth improving that response time or not. And you can see here for 200 milliseconds, our study shown that for this specific scenario, the difference in conversion would be 6.58%. We actually had to weight in that because not all the people arrived on the product page. And when we weighted in, it was 4.28%, which resulted in an estimated lift of $21 million per year. That's quite a high value, right? So from this dashboard, you would say, okay, let's do this. However, there's a catch, and you'll see it later. Just seeing this correlation, let's say, wasn't enough for us. We wanted to confirm the hypothesis, right? We said if the response time improved, the conversion will improve by this, but will it actually improve? And this was actually it's actually the hardest part. You have two ways, might be more. We thought about two ways of checking the actual gain. One is comparing two periods. One when we had a slow response time, and one when we had a fast response time. But then you're not really excluding other variables. And this is when the difference between correlation and causation comes in, right? And you have this picture on the right. During dry, hot, and sunny summer weather, people tend to eat more ice cream. So this, we can say that the weather causes people to eat more ice cream. And also this dry, hot, and sunny summer weather causes sunburn. If we would check for a correlation between ice cream, I wanted to say usage, but yeah, between the number of people that eat ice cream or ice cream sales, let's say, and number of sunburns, we would see a correlation, but there's no causation between those. It doesn't mean that if people eat more ice cream that they get more sunburns, as well as it doesn't mean that if people get sunburns, they'll eat more ice cream. Or at least I don't know that way. I don't know this as a remedy against sunburns. The other way of checking the actual gain is through A/B test. A/B testing, and this is actually the recommended way, because whenever you do an A/B test, you keep all the other variables excluded. Of course, that means you have an A/B test engine, and that engine randomizes the user data as good as possible. What an A/B test means, for those of you who haven't seen this before, is that, let's say, 50% of the users get one variant, the other one gets another variant. It's usually called control and treatment, just like in pharma studies, right? So 50% of your users will have, let's say, the website behaving as it is right now, and 50% of your users will have it, your website behaving faster. After you check the actual gain, you'll have to fine tune the model, because you might get some conclusions that your initial model isn't quite the same as the reality. And then you just repeat these steps and try to improve the whole process. How we did it? First of all, the easiest way was looking to check the two periods. We knew that since January, we had 14% improvement in median latency. We were in August. And when we checked the conversion, we saw a 10% lift. But it's not just the overall conversion of the website. We looked into specific cohorts of users being at the same response time as compared January to August. And this actually gave us a glance that we're on the right track. And we might have said at that point, okay, we've confirmed our study. Let's use this from now on. However, we were still not that confident. It seemed too good to be true, let's say. So we wanted to keep checking. Next was trying to do some A/B testing. And we've started with performance improvements. We had our engineering team work on those improvements. Whenever they were ready, we would deploy those improvements through an A/B test, meaning 50% of the users were still on the old version, 50% on the new one. And the first thing that they managed to do is improving latency with 50 milliseconds. We ran that test. We ran it for a week or two. We saw no immediate change in conversion. We say, okay, 50 milliseconds, it's not actually, you can't feel that difference. So we have to go higher. Again, the engineering team worked a lot, tried to improve the conversion, the latency. They managed to do it by 120 milliseconds. We ran the experiment again, no change in conversion. By now we were thinking, okay, these values might be too low. How can we actually confirm this or not? It became quite hard to improve the latency even further by, I don't know, 500 milliseconds or 1 second, because we were already in a pretty good spot from that perspective. So the next version we've tried was negative A/B testing. What negative A/B testing meant for us was purposely increasing the latency. Again, we've tried with 50 milliseconds. We saw no change in conversion, although our model estimated a 2% cost, a 2% loss in conversion. And we actually had to convince the C-level to run that experiment, because they were saying, okay, we'll lose dollars. What are you doing here? And we'll say, okay, it will worth on the long run. After this, we were saying, okay, no result. Let's try to increase latency by 100 milliseconds. Again, no change in conversion versus 3.5% estimated loss. Let's go even further, we said, and we ran experiment number 3, in which we increased latency with 200 milliseconds. Although we estimated a loss of 5%, we saw no change in conversion. We said, okay, we have to go big or go home. So we went to the C-level and proposed a 1 second increase in latency. They told us no way, because that would cost them, at least the estimated loss was over $1 million in 4 hours of testing. So they said, okay, we can't even put the threshold to stop this experiment fast enough. We don't want things to go that south. You need to come up with another way. And at this point, we were again scratching our heads. It looked like we were trying to find the needle in the haystack. It was really weird for us, because we've worked a lot on trying to really understand this. We've looked into all possible variables. We've tried to exclude all kinds of things. We've seen this correlation disregarding the device the user uses, the region. Again, something looked off. And while we were still looking for some answers, by mistake, we left the experiment number 3 running. And it ran for 3 months when we received an alert that the experiment finished, and finished negatively with a 3% decrease in conversion, which was, and it was statistically significant. So all other variables were excluded. So we were so happy at that point that we were able to confirm our hypothesis. Although we estimated the loss of 5%, the actual loss was 3%. So a 3% decrease in conversion, and that allowed us to fine tune even better the model to weight in that difference. So whenever we use that model afterwards, we put we multiplied it by 3 over 5% in order to have closer values to that. And that gets us on the studies on performance page. Like you've seen, other companies have confirmed it. We were able to confirm it as well with 200 milliseconds delay on the product page, because again, I've talked about these experiments, they were strictly done on the product page. The actual result was -3% in sales, and in theory, a 1 second improvement equivalent to sales, it would be over 10%, just like other companies have seen before, but it was really nice for us to be able to actually pinpoint this. So if you look at the values on the right, where we've tried to estimate the 1 second improvement equivalent, we see Amazon saying plus 10%, Google saying over 20%, Strangeloop saying 7%, Tagman 7%, Global Dots 8%, and we were somewhere over 10% with 10%, which again we try to keep it as conservative as possible in that way. So yeah, we've seen that latency actually impacts conversion, and it impacts it in a big way, because we're only talking about 200 milliseconds delay in this last experiment that we ran. And if you think about it, if a page type, if a website loads in 1 second or 1.2 seconds, you might say, okay, it's the same. What does it really make a difference? Well, it does, because over time, people will see that drop in performance. Likewise, they'll see an improvement in performance over time, and they'll get used to that performance. And another thing that counts here is the industry benchmark, of course, because if most of the websites that people access have a good response time, if they go on your website and it's quite slower, you'll definitely have an impact there. That's what I wanted to tell you about. I hope you find it interesting, and of course, I'm ready to take any questions if you have those.
Thank you, Victor. One question: when doing A/B testing, you said that you could increase the latency of the website being viewed by 1 second, let's say, as the maximum. That second actually costs the ones testing it, right? Because you're delivering that slower website to 50% of the users.
Yeah, that's correct. I mean, we knew that when we will want to run those negative A/B tests, that will do some damage, let's say, to the business. But it was controlled damage. We were able to estimate how much will that experiment affect the business. And like you've seen, until 200 milliseconds, C-level was okay with it. But once we got to 1 second and that huge figure that they saw in terms of loss, they said, okay, no way, we're doing this.
Right. So there wasn't any way you could do it the other way around, just increase performance, like 1 second less.
Yeah, it's quite hard to do that. If you have a really bad performance, let's say it's easy to do it. But if you're already in a pretty good spot, it's harder and harder. It's just like with car speed, right? It's easier to get to, I don't know, 200 kilometers per hour, but then it becomes harder and harder. And if you look at the world record in terms of highest speed, it becomes harder and harder to pass it, disregarding how many horsepower you use.
Right. Well, thanks again, Victor. Thanks for being here.
Thank you. Really glad to be here again. And yeah, hope you enjoyed it and have a really nice day.